Hi, in this video I want to talk to you a little bit about Pytorch version 2.0, which is the most recent version of Pytorch with some substantial changes to the deep learning library of Pytorch, which is arguably the most famous deep learning library used in research specifically and in industry as well. First, let me give you actually a very short summary of what this is about. So if you want to use Pytorch version 2.0, it's going to give you a lot of nice options such as accelerated running of your models. So in many cases, it's going to help you easily improve your model and make it faster in terms of execution. So all you need to do is to install it using the nightly build, because it's currently only available there at the time of this video. And in order to use it, when you have to find your model, you just have to do compiled model, or the model itself, and you have to run torch.compile on your model, and this is going to take care of a lot of backend related stuff that makes your model a lot faster to do. So they mentioned that unlike the previous approaches in this domain, such as torch script and JIT trace and things like those, this is going to be able to work. So this is going to be able to alter models, and in 90% of the cases it captures the graphs efficiently, and it's going to lead to a lot of improvements. So in short, if you want to use Pytorch 2.0, install nightly and run the model compilation using torch.compile. So let's go through the announcement and see what else is new, and what kind of things are going on in the back end that helps basically achieving this type of improvement. So in the past few years, Pytorch went from version 1.0 to the most recent 1.13, but instead of 1.14, they moved to the Pytorch 2.0. So Pytorch Foundation was also the part of the Linux Foundation. Pytorch 2.0 is going to offer the same eagerness of the Pytorch API and the user experience that it had, even though a lot of things are now supercharged and a lot better. One of the most important things is the providing faster performance and support for dynamic shape, and also being compatible with the distributed setups such as distributed data parallel and the FSDP. They mentioned Pytorch 2.0 is faster, more Pythonic, and as dynamic as ever. So again, torch.compile is the main thing that has to be done in order to use and take advantage of Pytorch 2.0's functionalities. It's going to move parts of Pytorch from C++ back into Python. This is going to be the substantial direction for Pytorch. That is why they called it version 2.0, because it's a substantial change to the system. Now, what's new in Pytorch is Torch Dynamo, AOT Autograd, PrimTorch, and Torch Inductor, which is the compiler. So Torch Dynamo is going to capture Pytorch programs safely using the Python frame evaluation hooks. So this is going to be a significant change. AOT Autograd is going to overload Pytorch's original Autograd engine as a tracing autodiff, and it's going to generate ahead of time backward traces, help with accelerations, etc. PrimTorch has to do with the primary operators and primitive operators, and it canonicalizes over 2,000 Pytorch operators into a closed set of around 250 primitive operations. And the advantage of this is that it lowers the barrier of writing a Pytorch feature or backend, or basically helping the development of Pytorch. And then there's Torch Inductor, which is a deep learning compiler. It's going to generate fast code for multiple accelerators, such as NVIDIA GPUs. And it uses OpenAI's Triton as a key building block. To validate these things, they have had a diversity of 163 open source models across various machine learning domains. They built this benchmark carefully. They had object detection, image generation, various NLP tasks, language modeling, QA, sequence classification, etc. They have 46 models from Hugging Face, 61 from TIMM, 56 from Torchbench. So all of these are done in the Pytorch 2.0 by just adding the torch.compile, and easily the advantage of speedups have been visible. In the case of mixed precision and in the case of Float32, there have been improvements in the speedups, but there are still caveats, such as there are other GPUs that are not supported and things like that. The primary maintainers of many packages have talked about this. For example, for the Hugging Face Transformers package, the maintainer mentioned that with just one line of code, they have a speed of 1.5 to 2 times in training the transformer models, and other packages have also, other major developers have also confirmed that this is the case for using Pytorch 2.0 with their own systems. In terms of an overview of the technology, there's Torch Dynamo, which is going to acquire graphs reliably and fast using the frame evaluation API. They have used over 7,000 GitHub projects within Pytorch as a validation set for this. Torch Script and others struggled with those, but Torch Dynamo apparently acquired the graph 99% of the time, so it's a better way of graph acquisition, which is going to be important. Torch Inductor is going to be a code gen, and it's defined by run. The AOT autograd is going to be a faster and better autograd by also reusing it as well, using the Torch dispatches extensibility mechanism. PrimTorch is going to be stable primitive operators, so you can see that those 2,000 are kind of brought down to a more manageable amount of Pytorch operators. So as you can see, these core functionalities and all of those are kind of nicely maintained by Torch Prim. In terms of user experience, all you need to do is to do the torch.compile. Compile is going to have certain arguments that you could use. These arguments would help you to better manage the trade-offs and the output that you want to get. For example, the first one is mode, which there are options such as reduce overhead or max autotune. For example, max autotune is going to compile for a longer time, trying to give you the fastest code it can generate. Reduce overhead might be more useful with the smaller models. There's this dynamic bool option, which is defaulted to false. This is going to be whether or not to enable the code path for dynamic shapes, knowing that when you enable the dynamic shapes, there are certain optimizations you are not able to do. Therefore, just adding the option to set that is going to be very important. Full graph is going to be similar to Numbers No Python. It's going to compile the entire program into a single graph or give an error explaining why it cannot do that. There's the backend, which specifies what compiler to use, Torch Inductor being the default. Then again, the sample code is over here. You can see that you can have a code very, very generic. Everything is the same as before, only this line is added. So you have compiled model, which is torch.compile, and it can take care of that. Also, the model attributes can be used the same as before, and Torch Dynamo helps with that. Hooks for module and tensor currently not working fully. In terms of serializing the model itself, I'm not quite sure about this, but apparently it is. You cannot serialize it currently like that. You have to, save the state dict and then load the state dict like that. So, but it's not going to be like the original modules that can be serialized. There is also the export functionality that they have been working on, the Torch Dynamo export. So in many cases, let's say you want certain predictable latencies. So similar to, let's say, tracing, you have model, you have input, you give it to Torch Dynamo export, and you get an exported model, which you can apparently serialize, but I think it's not functional at the moment fully. In terms of debugging the issues, when you go to the compiled version of code, usually it gives the impression that it's harder to debug. Originally the reason Pytorch, in my opinion, was a lot more straightforward to use it rather than the earlier version of TensorFlow was this easier time debugging the issues with the model. So in this case, there are options for that. They have the minifier that has been added. It automatically reduces what you're seeing to a small snippet of code. If not, there's also the Torch Dynamo explain, which explains what part of the code initiates a graph break, such as things such as printing and things like that. And it would help, with debugging. The dynamic shapes can be done by setting this dynamic equal true argument here, and it would take advantage of other things in order to make this dynamic happen. They show that in the case of dynamics optimizations, this still is going to be better than the Pytorch 2.0 static shapes and padding. So it's going to be kind of on par, and it's going to be compatible with different dimensions. In terms of distributed learning, it is compatible with the fully sharded data parallel and the distributed data parallel, and it is going to lead to improvements in performance. So all in all, it's a major step in the right direction. In terms of installing it, as mentioned before, you have to install it using the nightlib build. You have to do it like that, and you can verify it like this, or do a Docker installation. So, what is Pytorch? Version 2.0 is the most recent version of Pytorch. Why 2.0? Because instead of going from 113 to 114, because the direction that they have been moving towards is a major update. So they decided to call this substantial improvements, moving to version 2.0 instead. Installations are discussed. 2.0 is that backward compatible. It is not enabled by default in the sense that you have to do the torch.compile in order to take advantage of the major new upgrades. Migrating the code is just one line of code. Why should you use 2.0? Again, improvements. What is the code doing differently when using Pytorch 2.0? Is the graph acquisition is better using Torch Dynamo? There's the graph lowering and graph compilation. So again, these are all the new features. And how does distributed training work with 2.0? 50% faster in floating point 32 and up to 80% faster in the mixed precision, roughly. And there are like a lot of useful documentation websites and communities that can be used in order to learn more about Pytorch version 2.0. And one important question is question number 13. So if you add the Pytorch 2.0 functionality and your code is starting to be actually slower than before, they mentioned that the most likely reason is too many graph breaks. So for example, if you have something innocuous as print statement in your model's forward, it's going to trigger a graph break, and they want to build an article on how to diagnose these types of graph breaks. And that concludes our overview of what Pytorch 2.0 is, and I hope you enjoy using it in your machine learning projects. As always, thank you for watching this video.